Hi, I'm Thomas Bukta.
I'm Chandler Greer.
I'm Nick Holton.
And I'm Joe Felly, and we are Group 2 in IE 441 Senior Capstone Design. We are working with Company X and Dr. David Sly.
With the company, we determined three overarching objectives. The first was to increase the facility's monthly throughput by 74%. The second was to redesign and expand the facility's service department. And lastly, we wish to improve the facility's external storage space.
The first step in our current state analysis and solution approach was to put together a current state layout. This included all operation and machine footprints, work and process areas, parts and tool storage zones, and then later we came together and created this in AutoCAD to help with future layout iterations.
Using the current state layout, we created two separate departmental material flow diagrams. One of these is a straight flow diagram showing material flow between departments, while the other is a material flow diagram showing material flow between aisles within the facility. These depicted excess exterior transportation, clustered transportation hallways, and dominant relationships within the facility.
With our material flow diagrams in hand and our time study data at the ready, we started making a value stream map. The value stream map communicates to us operation cycle times for each station, along with the individual inventory storage buffers and any external services or supplies that need to enter the facility.
This brings us to our relationship matrix and diagram. With representatives from the company, we use the relationship matrix and diagram as a planning tool for analyzing, displaying, and finalizing relationship data between departments. This was then used in determining our future state design ideas.
Lastly was the production capability analysis. This involved making a precedence cycle time bar chart, which depicts the process in terms of true one-piece flow along the core assembly path, along with identifying parallel processes and their frequency. The table was then used to evaluate the current monthly production capacity of each station, later used to determine the necessary expansion, indicated with the delta.
From our thorough analysis of the current system, our team came up with these four design iterations that fit with what the client could have wanted. All these iterations are based on a central flow through the facility with surrounding stations feeding in. We then collaborated with the representatives from the company to flesh out our last designs and determine where to go with our final design.
This is our final design. Our final design involved a 68% facility expansion. All the changes are represented in orange. The dashed yellow line represents the current facility limits. This design promotes straight line flow through the main assembly line, eliminates unnecessary exterior transportation of assemblies, improves interdepartmental flow, and expands the facility's service, parts, and office departments. Additionally, a warehouse has been placed on the grounds for exterior storage.
This comparison of the current state material flow diagram and the future state material flow diagrams allow us to visually represent the changes made to the material flow within the facility and how we have improved it.
The last step of our project was to compute the 3-year internal rate of return. For this, we considered the initial investment for machines, the necessary expansion, and the exterior warehouse. In addition to that, we included the expenses added due to labor costs. Lastly, we considered the projected additional revenue for the new units being produced, accounting for the costs of goods sold and costs for sales, general, and administration. In the end, we found a 3-year IRR of 32%. Thank you for listening.